we can rewrite our integral because we have x to negative 2 power, so we will have integral from 0 to 2 of x to second power natural logarithm of x with respect to x. Now we have here interval from 0 to 2, and we have here natural logarithm of x. We cannot find value of natural logarithm of 0. Let me remind you the graph of natural logarithm. This is 1, and it's like this. When we are close to 0, our graph going to negative infinity, and we never pass our y-axis. So we can find only value of natural logarithm for positive numbers. It means that for x equals 0, our integrand is discontinuous. So we have to rewrite our improper integral to limit. We can put t goes to 0, y to 0, because for 0 our integrand is discontinuous. Our integrand is continuous in interval from 0 to 2, we can write. So when we are going to 0, we are going from the right side. So we have to use right hand limit. So we have t goes to 0 from right. And now we can rewrite our integral from t to 2 of x squared natural logarithm of x dx. So now we have to find this integral first. Let me copy. We have integral of x squared natural logarithm of x dx. Because we have natural logarithm, we will integrate by parts. We want to reduce natural logarithm, so we will put that f of x is equal natural logarithm of x. So f prime of x is equal 1 over x. Our g prime of x will be x squared. So g of x is equal 1/3 x cubed. When we take derivative of 1/3 x cubed, will be exactly x squared. Let me remind you this formula. Integration by parts, we have integral of f of x, g prime of x with respect to x. So this is equal f of x times g of x minus integral of f prime of x, g of x with respect to x. So now we have to just plug to this formula. So our integral is equal. We have f times g, so will be, I will put first 1/3 x cubed natural logarithm of x minus integral of f prime is 1 over x, g is 1/3 x cubed with respect to x integral. So this is equal. We have 1/3 x cubed natural logarithm of x minus, we can put 1/3 first, and we can reduce x with cubes. So it will be x squared, integral of x squared dx. So this is equal 1/3 x cubed natural logarithm of x minus 1/3 integral of x squared is equal x to power third over 3. Now we can factorize 1/3 x cube, and we will have in parentheses natural logarithm of x minus 1/3. So we solve our integral. Now we have to come back to our limit of definite integral. So this is equal. We have to copy limit. T goes to 0 from right. And now, because we have definite integrals, so we have to put the solution. And we have to plug limit of integration. We have from t to 2. So this is equal limit. T goes to 0 from right. And we have to first plug 2. So it will be 1/3 2 to third power, and in parentheses we will have natural logarithm of 2 minus 1/3, and now we have to plug lower limit, so it will be minus 1/3 t cube, and in parentheses we will have natural logarithm of t minus 1/3. We have limit t goes to 0 from right side, and we have, I can put this in brackets, like difference of two expression. First expression doesn't have t's. The limit of this expression will be equal to this expression. So let me rewrite that this is equal 1/3 times 2 to third power is 8/3, and we have natural logarithm of 2 minus 1/3. And we have to subtract the limit. T goes to 0 from right, and we have 1/3 times t to third power, natural logarithm of t minus 1/3. So now we have to solve this limit. Let me copy this expression. So we have limit t goes to 0 from right, and we have 1/3 t cube. We can do multiplication times natural logarithm of t, and we have minus 1/3 t cube times 1/3. So let me put this in parentheses. So this is equal. We can rewrite this to two limits, and I can put constant before limit. So we have 1/3, and we have limit t goes to 0 from right. We have t cube, natural logarithm of t minus, and we have limit t goes to 0 from right. 1/3 times 1/3 is 1/9 t cube. So this is equal 1/3. We will rewrite, and we have limit t goes to 0 from right. I can rewrite this multiplication to natural logarithm of t over t to negative third power, and we have minus. Here we have only multiplication, so we can substitute t by 0, so it will be 1/9 times 0 is 0. So limit on this expression is 0, so we don't have to write minus. Minus 0 still will be the same, so this is equal 1/3. We copy, and now we have limit t goes to 0 from right, and let's see what we have here. Natural logarithm t goes to 0 from right side, so natural logarithm going to negative infinity. Let me remind you, we have graph here. When we are going to 0 from the right side, so our natural logarithm going to negative infinity, going down. So we have negative infinity in numerator. And in the numerator, t goes to 0 from right side, so we have very, very small number. Very, very small number when we take 2 negative power, we will flip this number. It will be very large number. So we have very large number in denominator. So when we have infinity over infinity, we can use L'Hopital's rule and we can take derivative of numerator. Derivative of numerator, natural logarithm, is 1 over t, and derivative of t to negative power is negative 3 times t to power negative 4. So now we have 1/3 times limit t goes to 0 from right, and we can rewrite that this is equal 1 over t times negative 1/3, and we have t to negative 4 power, so it will be times t to 4th power. This is equal, we have 1/3 limit t goes to 0 from right, and now we can reduce t with t to 4th power will be t to 3rd power. So we have negative 1/3 t cube. Because we have only multiplication here, so we can substitute t by 0. So we have 1/3 times will be 0 to 3rd power is 0 times negative 1/3 will be 0. So we have a limit as t goes to 0 from right side is 0 of this expression. So 1/3 times 0 is 0. So now we can come back to our limit. This goes to 0. So our solution will be this expression 8 over 3 times natural logarithm of 2 minus 1/3. Because we got finite number, it means that our improper integral is convergent. This is my solution.